Hi everyone, it's Judy. Welcome back to the On Track podcast. According to an Aberdeen study, 61% of your time as a busy PCB designer is spent on doing non-direct design-related activities such as sourcing components, document control, version control, and so many other things. So I've brought Chris Carlson, Snr FAE here at Altium, into the studio to talk about ways he's discovered over the course of his career to keep those things that keep you in the weeds to a minimum and help you be an effective designer. I hope you'll enjoy this podcast with Chris Carlson. Welcome to Altium's On Track podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, Chris, thanks so much for joining us on the On Track podcast today. I'm excited to sort of share you with our On Track audience.
Well, Judy, thank you for finally inviting me to your yellow chair green room.
Our pleasure, always. So, Chris is a Snr FAE here at Altium, and I thought maybe you'd like to get a sort of peek inside of the work that Chris does here, besides cracking jokes in the hallways, because he does a lot of that. We enjoy that, though. So why don't you share a little bit about, sort of what your day-to-day or your week-to-week is as a Snr FAE at Altium.
All right. Well, it's actually pretty diverse. Obviously, one of my major roles is functioning as a technical resource to the sales team. I interact with customers a lot, do a lot of product demos. We go on site, which is actually a pretty cool part of the job because I get to see the stuff that our customers and potential customers are doing. And we got some customers doing some pretty amazing stuff. Mm-hmm. Things like this for you guys, I've done quite a few of the Whiteboard videos, and I write technical papers and marketing content, as well as now podcasts.
Now we've rounded out your whole portfolio.
Yeah.
So you were a designer in your former life. So tell us a little bit about your background and what maybe windy path brought you to the industry.
Windy path.
Yeah, we all have one, Chris.
Yeah, we do. Well, like a lot of people in this industry, I started out as kind of a nerd kid. I was always into science projects, looking at bugs under microscopes. And when I graduated high school, I went to a community college and I got a 2-year technical degree as an electronics technician. And I worked in that field for about 8 years. The last 5 of it were in a hospital, keeping basically everything in the hospital running, which was actually a pretty interesting job in of itself. But after my time there wasn't really anywhere else to go. So I went back to school and got an electrical and electronics engineering degree. After that, I started out in industrial controls, and then I was hired on with a small startup company to be a development engineer on a motor drive project. And Dr. Alan Plunkett and Carl Konechny were my mentors there. Carl's probably one of the sharpest controls engineers I've ever known, and Alan's got a pretty big image, if you will, in the power electronics industry. From there, I wandered around to a few different startups. I know a lot about what it takes to make a startup fail. Don't know too much about what makes them succeed, but I've seen a half a dozen or so fail. And then I ended up at General Atomics. I worked on the electromagnetic aircraft launch system. And one of the things that is always troubling for every engineer is that every project is always over budget and behind schedule, and it's always your fault.
Of course it is.
So this opportunity with Altium came up, and I thought, well, that might be something to do for a couple of years, and it's been a pretty long run.
Yeah.
It's a really fun job, and it's very diverse, and I've really enjoyed the people here, the atmosphere, as well as the diversity of the job.
So how long have you been with Altium?
Going on 12 years.
Wow, so you've been here a long time.
Yeah.
I didn't ask you that before our recording this. So.
One of the old guys.
Yep. So when you were, in the field designing, what were your personal favorites, like your favorite things to do that were part of the job, and your least favorite?
Probably the favorite would be looking at problems to solve and coming up with creative solutions, breadboarding something up and actually watching it work, all the way up to getting a prototype board in your hands and watching it fail and doing it again. But yeah, the whole design aspect of it is really, it can be very rewarding and a lot of fun.
Yeah.
Least favorite, is all of the busy work you got to do. To properly develop a product and get it into the market takes a lot of backside stuff you have to do. I mean, everything from sourcing parts, tracking engineering change orders, tracking things in spreadsheets, design documentation, fabrication drawings, assembly drawings. I used to have a spreadsheet as a checklist. Okay, I've got my Gerbers, I've got my bomb, and so on. And that's just always a huge hassle. It's painful and nobody likes to do it.
Yeah. Well, to your point, around here we've talked about this Aberdeen survey that we've looked at that says, up to 61% of what designers do is not designing the board.
I've thrown that out to a few of our customers, and they usually chuckle and say, really? Only 61%?
Right?
Yeah.
I bet it doesn't feel like that. So maybe Aberdeen was all wrong. But talk about what designers can do to be more efficient, to enable them to spend more time in that creative process. That's something that's sort of near and dear to our heart here. Things that we think about when we're developing the tool is how do we streamline some of those things inside the tool, right, to help designers get there. But just, from a general standpoint, what are things that designers can do to be more efficient in those, those things that keep them in the weeds too much of the time?
Right. Well, design reuse is always a big one, A lot of your ECAD tools nowadays have facilities to take circuits that you've previously developed and then reuse them. If it's something you've actually built, you've proven it out, it works, the parts are purchasable, and that you can actually build it.
Yeah.
And so, if you can build up a library of, maybe that switch mode power supply you tend to use over and over again, or a Bluetooth interface or something, it's something you can just draw from, grab it, and put it into your design, and that part of your design is done.
Right.
Along with that, creating templates of all of your documentation standards. This way you're documenting a design consistently the first time, every time, according to your corporate standards. It's correct. It's all of the information your fabricator and your assembler needs to get the job done. So often I see people, when they're finished with a design, they package up the Gerbers with a README file and say, hey, go build it. Now,
I have been on the receiving end of that deal, and let me tell you, it sucks. It causes so many phone calls back and forth. So as a fabricator or an assembly company, I can't tell you how many. It's like, oh, here's a Gerber file and a README file. And good luck. Have a nice day. And it's like, material? What kind of material? How thick? What are the tolerances? Just so many, it brings up so many questions. So then the phone calls or the emails start back and forth, back and forth.
How do you even quote something like that?
Well, it's terrible. You can quote it, if you have sort of a baseline of information, you can quote it pretty easily, but But what happens sometimes is like, oh, did I tell you that layer 3 was Rogers 4350? Or whatever. I mean,
Exactly.
things can come up that, throw the price off. But typically the quote can be done easily. But as far as building it the way that it was intended,
Right.
there's so many questions. And building bare boards and assemblies, it's just very complex. So anyways, I've just been on the catching side of that equation, and it shocked me. I left the industry for 12 years and came back, and that's the number one thing that shocked me was the lack of documentation. Because when I left, there was still documentation, and I'm like, people, where's your documentation? But along those lines, about the templates that you're suggesting, sometimes is there a risk, or how can you avoid the risk of, say, templatizing something and forgetting to modify something in your standard notes that might be, something that's changed? Because I've heard for other fabricators, it's like they left this note in.
They have their standard note section,
yes,
and they just go with it.
Yeah. How do you avoid that? Or
where I actually finally got a handle on this, it was a number of years ago. After the succession of long email chains
yes,
and phone calls, everything you described, I actually sat down with our fabricator and our assembler. I actually sat down and discussed it. What do you need to get this done and get it done right the first time?
Yeah.
And they gave me some examples of standard note sections, things they need. As you pointed out, what's the material? What are the thicknesses? What's the layer stack? And all of this needs to be called out.
Yeah.
Your minimum
weight,
annular ring, your drill drawing with your drill table, so they know how many tool changes there are, and everything that goes along with that. And I actually had a template of probably a half a dozen fabrication drawings for different geometries of boards, different layer stacks. And I had a standard note section, but then in red, I put in XXXX for those things that you're going to have to fill out that are unique to every design.
I see.
And, you just stare at that and go, oh yeah, I need to put this in. And that was really helpful.
Oh, that's a great idea.
You will need...
By the way, I've gotten those drawings that just say XXX, but not in red.
Well, if you put it in red, then you'll notice it.
So I've gotten the XXX, and I'm like, what is that? Because I think they meant to, but the red, I think, would help you.
Well, that's what I had to do.
Yeah.
Because it had to jump out at me and remind me, oh, I need to fill this out.
Yeah.
Right. Another thing, too, is, in your multiple templates, you're going to have different standard note sections for different types of materials and different technologies. And, so you have something to start with that's pretty much there for a particular design flow, and then, fill out the details.
Okay. That makes sense. I think that's some good tips.
And, there's a lot of things that you need to actually specify for them to get it right. If you have any impedance-driven widths and things like that, just throwing the Gerbers out there and expecting them to get it right, you don't have anything to hold their feet to the fire on. Whereas if you specify those things in your fabrication drawing, this is going to be 90 ohms for USB, and this is going to be 50 ohms for this section, and so on. Then when you get a board back and it doesn't work, you can go back and say, hey, look, I called this out.
Yeah, and actually Jerry Partita, who's on the podcast before, works at Summit Interconnect, he's like, that's your quality assurance document. This is what you compare about. So when it comes into back to the OEM and they have their boards and they have drawing, I mean, if it's a good drawing, that's what you're comparing it against.
That's right.
And so that's your blueprint. I mean, that's your... Well, and if not, and by the way, and if you don't do that and you just threw a README file over, then what will happen is if something was wrong, then you get into this, finger pointing situation, right?
That's right.
Where then the board manufacturer, if they're they don't have good scruples, can just say, oh no, you didn't put it in the files, it wasn't me, it's on you, you paid for it, right?
I've actually had fab houses that have not done a diligent job of reading my fab notes, and they gave me something different.
Yeah.
And I've had to come back and say, hey, did you read this? Notice what I specified. Another thing another little trick I've done in the past is maybe off on a small edge of the board, route a few traces that are to your impedance specification, and when you get the board back, polish the edge of the board and look at it under a microscope and measure it and see if their fabrication process was able to do that correctly.
Oh, interesting.
Yeah.
Because
that's going to change from fabricator to fabricator,
it is.
process to process.
Yeah.
You know, if the chemistry has been used for a long time, you know, those things change over time.
I know, and I think that it just is what it is. But you know, obviously, most designers are so busy they don't know these things. They don't have the insights, right?
That's right.
To know that spent etchant is a problem, or dull drill bits, or whatever, and
Exactly.
that it might still be within
somebody's tolerance
or standards, maybe not yours.
Yeah, exactly.
So, anyways, I think it just opens you up to risk. So, I think I obviously have strong opinions about documentation.
Well, another thing too that's important is getting the layer stack correct. I've actually had boards come back where the layers were out of order.
Really?
Yeah, and you know, the board would electrically test okay because everything's connected, but now the particular planes that you routed your impedance-driven differential pairs and things to aren't in the right order, and things aren't going to work when you actually, you know, you could end up with an intermittent board and say, what's going on? That's really hard to figure out.
Oh, wow.
So a little trick you can do there.
Especially if they're in the middle of a 10-layer board or something.
Oh, yeah. And how are you going to know?
Yeah.
There's a technique, I think they call it stacking stripes, where on the edge of the board, and there's some specifications for this, you basically put a trace that's maybe 200 mils long on the first layer, 400 on the next layer, 600 on the next, and so on. And then again, you can polish the edge of the board, and you can see those layers stack up, and you know they're in the right order.
That's a good trick. Actually, didn't you do a whiteboard series? No.
Yeah, I did.
Was it whiteboard series?
It was one of the whiteboard series.
Okay, I'm going to share that in the show notes below because it was really good. It was really well received. It was something people didn't know, and I've also seen it done where they actually put the numbers 1, 2, 3, 4 staggered.
Yep.
So you can visually see,
you can visually see, one, you know, all the layers are there, and two, you know they're in the right order.
Exactly, yeah. So that is a good, so we'll share that one. That's a good one. What about part sourcing? Like
that's always a big one.
I know that's kind of a big can of worms to open up, right? But
oh man,
what can you do to stay out of so much of the weeds in that department?
There's a lot of weeds to get into.
Yeah.
I remember one time I designed in a component from a particular manufacturer, and they had some really cool parts, but they didn't have any of their own fabs. So they were going to the other big fab companies and getting time in their fabs when they could. And so part sourcing was a big issue. And I didn't know that. And I designed this in, and about 6 weeks later, the VP of engineering sent out an email to the entire engineering staff, "You will not design in components from this manufacturer again." Kind of directed at me. But yeah, you know, end-of-life components, how do you know? Not recommended for new designs and so on.
Yeah.
Places like Octopart can help out with that.
For sure.
Another thing you can do too is look for several sources of the components that actually have high volume stock. Because, one, that's going to tell you that a lot of people are using it. They're stocking a lot. It's readily available.
Right.
There are tools that do have the ability to show you up front what the manufacturer's life cycle is, and that's a big deal.
Yeah.
As well as the supply chain information. Does anybody actually sell this? Because, if it's not a component that's readily used in industry,
right.
That might be a sourcing issue as well.
For sure.
It really is a bummer to get a design complete. It's out the door, it's behind you, and 2 days later procurement comes back and says, hey, I can't get some of these parts.
Yeah, yeah, because and they were available when you were doing your schematic.
Or you didn't pay attention.
Either way.
Been guilty.
Yeah, well, it's easy to do. It's a lot of load to carry. A lot of people like our Active Bomb. Not to shamelessly plug our own tool, but I know that's been good, but Octopart as well.
Yeah.
Being able to actively see, what's out there and what's available and get a good glimpse.
Yeah. Well, you brought it up. So Active Bomb is an incredible tool. It shows you real time the cost that you're designing into your product, and it shows you all of your manufacturer's life cycles right there as you're designing. And it shows you any supply chain issues that you have, so you can rectify that up front, so you don't have procurement coming to you and saying, hey, you got to do something different.
And actually, I wouldn't know how great Active Bomb was. I know what it is. I know that it's there. But, hearing it from our customers, actually saying, oh, I love it, that changed my life or whatever. So actually hearing it,
Right.
So there's the shameless plug for Active Bomb. And if you're not using it, you should, because it's a really great part of the tool. Version control.
Version control. Wow. That can take on a whole life of itself. The standard approach to version control is you use a third-party tool like GitHub or Tortoise SVN, CollabNet. Check your product or your design files out of the repository into a local working copy. Get into your CAD tools, make your changes, and if you remember, go check everything back in. A lot of the ECAD tools nowadays have built directly into the UI capability to plug into these standard version control tools. Use it. Use it religiously. It solves a bunch of problems. You have the entire evolution of your design in the repository. You'll be able to compare earlier versions to the current version. You can revert back to earlier versions. Let's say I start a design with a particular microcontroller. Somewhere along the design cycle, I realize it doesn't have enough horsepower, so I switch to a DSP. Then down the development cycle, something that never happens, the spec changes. And gee, I wished I had that earlier design. Well, you do. You've got the entire evolution of your work in the repository. You can go back and compare, your various revisions, find the one you want, revert to it, and pick up where you left off. Some other things it brings to the table, the ability to have traceability. Who did what, when they did it, and if they're good with the notes, why they did it.
Right.
A lot of your automotive, aerospace, biomedical companies require that.
Right.
Use it.
Yeah.
It's going to make your life much better.
Yeah. I can't remember who was just telling me that they were so religious. Oh, it was Jeremy Blum. That he was just like hyper anal about those notes, but he's like, it has saved me more times than once. Because I go back, I'm like, I don't remember why I changed something. But then I wrote the note.
Yep.
So he saves himself from himself. So when you are going back to your role as FAE, when you're demoing the tool, our tool, I imagine you go down sort of a list of things that you're showing.
There's a flow.
There's a flow,
that makes
right?
Logical sense.
So is there any certain part of that where they stop and they go, oh man, that's going to save me time, or that's are there do you see sort of trends and things that sort of catch designers' attention in regards to like saving time specifically or being more efficient?
Well, having a UI that interfaces to version control is a big one.
Okay.
The active route, it's not an auto router, it's an automated routing assistant. Saves you huge amounts of time. Being able to create project templates where you've pre-configured your documentation standards and then templates of those documents with not just your title block reference zones and sheet sizes, but the placement of where you want your layers stacked, where you want your notes, and all of the information. So as you hand that off to a fabricator or an assembly house, they're looking at a consistent document.
Right.
And again, you need to work with them to see what they require to get the job done right the first time, every time. And that's a big one. Our tool saves people a lot of time in that whole back end process. Multi-board is a big one. I've done that in multiple products in the past. And when you have multiple people working on different pieces of a design, they're interfaces.
Yes.
And it's not just the electrical portion of the interface, but the mechanical placement of that interface as well.
Right.
If one board designer has to move a connector or do some pin and part swapping in there, how do you communicate that to the rest of the team?
Right.
Spreadsheets, emails, notes on whiteboards, Post-it notes.
Yeah.
And it's a really arduous thing to have to manage. And if your tool supports that, and Altium Designer does, but there are other tools out there that support that, that can be a big time saver, because you're not going to end up with two boards that don't mate or they don't fit into the enclosure properly. You know all of that up front, and you can engineer things from a system level rather than, everybody off in their own little corner.
So let's just say it's the 61%, just
all right.
that,
we'll use
or
that.
the 92%, depending on what
depending on who you're talking to.
What is, if you're not managing that effectively, so all those details don't fill your every waking hour, what is the sort of cost of not managing it well?
Well, the cost can be success or failure of the company, literally. If your design cycles, if you're over budget and over time, in order to get the product complete, you can go through spins on design cycles. That costs money, it costs time. You might not enter the market before your competition does.
Yeah.
Okay, so now you're behind schedule, so you start backing out features and functionality to get, version
date.
1 out there to hit your date,
Yeah.
and your competition releases something that's much more feature rich, and they acquire the market segment, and you just missed out. Another area where people neglect that is in their library management. I see people do all kinds of crazy things with libraries. Every once in a while you come across somebody that's got one resistor, one polarized cap, one nonpolar cap, one inductor, and so on. And they do a design, and then they backfill that with values and manufacturer's part numbers and things. It's like, are you crazy? And with that one resistor, they'll have everything from an 0102 to a 2512 footprint. And it's like, well, I'm just going to pick that on the backside, the one I need. And it's like, how do you think you're going to get that right? Your libraries have to be golden. If your libraries are golden, you can pull parts with reckless abandon and get a product that's manufacturable.
Yeah.
If you're not paying really close attention when you're building out those libraries,
Yeah.
You're going to have parts that can't go on the board, or other, ramifications that flow downhill. Your bill of materials won't just flow.
I know. Right.
It's a big deal.
It's a big deal. My favorite story, I don't know if you ever saw the podcast I did with John Watson, where he talked about them having rogue libraries. Did you ever hear this
No,
story?
I've talked to John about some of this stuff in the
So
past.
he said that at Legrand, he's over like, I don't know, 50 designers there or something here and abroad. And he said they kept creating their own one-off, what he called rogue libraries.
Right.
And it was like Bob's library or whatever. And he said, stop doing that. You know, make sure everything's golden, put it in one, you know, shared library. Stop doing this. And they weren't listening to him. And so one Friday afternoon, he deleted them all.
Wow,
Like
that's a bold move.
1,200. He said there was 1,200 rogue libraries, and he hit delete. And I'm like, did you go to work on Monday? But from then on, they had one library, and it's golden.
Oh yeah.
It's golden, right?
Well, okay, you go to an your assembler, and they're having trouble assembling a board with a particular footprint. Whose library? What library did that come out of? What's the one that works? What's the one that doesn't work? If you're properly managing libraries, there's one component with that one footprint, and you know what needs to be altered. You know, we had a statistic one time, I don't remember what it was, but it was one of our larger customers told us what they thought. It was something like $1,800 for duplicate components. When it came down to the individual's time that it took to create it, trying to manage it and track it and everything, you know. And when you have duplicate components, errant components, it's just a big mess.
Oh.
Somebody needs to create it, somebody needs to check it, and then everybody gets to use it.
Yep. Yep. I think that would be probably the biggest time saver of everything, right?
Yeah, it takes time up front. And that's why people don't want to commit to it.
I know.
Because they're over budget and behind schedule.
I know.
You know, pressure's on.
I know. It's a it's not easy, you know. All this stuff, it's just so easy to sit in our yellow chairs and go,
Well, nothing in this industry is easy.
It's not. You know? It's not. Well, for our listeners, Chris you've also written a white paper, I think, about, what's the white paper you shared with me recently?
Oh, I don't remember the title, but it has to do with creating libraries of those neat little numbers that you see on the edge of a board showing that you have all of the appropriate layers, and then using stacking stripes to make sure that they are in the right order. So yeah, I wrote a paper on that, and I think we did a whiteboard on that too. So,
anyways, I pulled 3 or 4 things that that Chris has produced here at Altium, you know, the things, and I'll make sure that I'll share those in the show notes.
It's hard to remember all of the stuff.
I know.
We got piles of this.
I know. As much as designers are busy designing, we're cranking out content. Sometimes it's hard to track it down. So I can't imagine how they would go track it down, so I'm going to track it down for you. You know what I think would be really fun, Chris, is if we did this again, or you did a whiteboard video and basically taught about the documentation lessons that you learned back when you went to your fabricator and assembler. Or maybe refreshed it. It's probably
that sounds like fun, yeah.
Right?
Yeah.
Okay.
Go back, revisit that a little bit.
If you want to hear that from Chris, comment below, because I think it would be really valuable. But
she thinks you're making work for me.
Yeah. So if you want him to, let me know. If I don't hear from you, I'm not going to pressure him. So it's on you guys. Well, I think we're about out of time, Chris, but this has been really fun. We need to do this again.
This has been fun. Yeah,
right?
I love it.
Okay,
yeah.
All right, we're going to do it again. Well, to our audience, thanks so much for joining Chris Carlson and I today on the On Track podcast. Remember to like, subscribe, comment about, you know, the documentation thing that we want Chris to either shoot on a whiteboard series or
we'll do something.
Something.
Yeah.
It doesn't matter what format it is. So let us know if you want him to do that. We wish you a Happy New Year. We'll see you next time. Until then, remember to always stay on track.
And have a great decade.
And have a great decade.